Okay, now let's talk about the hairpinning pattern, another pattern we see quite commonly in enterprises. All right, so we've got our applications A and B. And instead of them talking directly to each other, right, we have a big API management proxy. And if B wants to call A, it goes back up, talks to the API management proxy, and it calls A. And if we want A to call B, it goes up and does this. And the main reason why people do this is because they need policy control at L7. Like previously, we've talked about DIYing or doing this at L3, and L3 just doesn't let you do things at the L7 layer. So you need some system capable of enforcing policy at L7, and because organizations have generally bought a lot of API management solutions, they tend to reuse what they already know how to use to solve that problem. And they get a lot of capability by doing this. But there are some fairly obvious downsides to this. One, the API management solution becomes a big SPOF, right? A big centralized point of failure. And we're all taught in computer science school that singular points of failure are not a good idea in large-scale system design, right? So if this is very large, and this is very, like there's only one or two of these, right? Then if this goes down, your whole network goes down, your entire system goes down. That's not what you want. The second problem is a pretty long path that this traffic has to take, right? Before A would go directly to B and vice versa. Well, now they're going up into some API management solution. There's a lot of policy being applied. And then it is in turn having to call down onto A, right? So we've added latency, clearly. And depending on the complexity of the policy and how efficiently the API management solution is built, right, we could have added a lot of latency. Like generally speaking, API management solutions are designed to satisfy the latency requirements of traffic coming from the public internet, right, from outside of your organization, where they may be thousands of miles away across, the continental United States or somewhere else, and therefore, they don't have to hit or have very efficient latency tolerances. Whereas if it's B calling A and they both reside in the same physical network or on the same VPC in your cloud provider, the actual latency between these two things could be very, very small, like sub-100 microseconds. And yet if the API management solution is adding 5 milliseconds, you slowed your system down by 50 times. So that's not necessarily great. And then the third thing is, well, where does this thing run? Even if you ran many of them, you may not be able to run them everywhere you run A and B, right? Maybe I'm only able to run this on my cloud provider, but I have a solution on-premise over here. And there isn't one of these on-premise. And so if C wants to talk to D, they have to go all the way up to the cloud and all the way back down. Right? And these physical latencies could be quite long, right? Like we talked about that from the public internet. These may be the same. Right, and now, we've made, again, maybe 2 orders of magnitude increase in latency. Worse still, if for some reason there's a network partition or a failure domain that causes this whole communication path to fail, then this system goes down even if other dependencies on it are functioning because they're not exposed to this. Now we have a big kind of zonal or regional failure domain that we didn't want, right? Because this may be regional, this is effectively zonal, and the system went out, right? So we have these kind of locality effects. Because of the likelihood or the unlikelihood that we're able to deploy this infrastructure everywhere. And probably last but definitely not least is these are commercial products in many cases. And people bought these assuming that they were going to pay for them based on the traffic coming from their public clients. Well, very often what you see is, the amount of traffic that's flowing between the internal systems in your network is far greater than the amount of traffic coming into the API gateway. And so if you were paying, $1 for every public API call, and every public API call turned into 10 internal API calls, well, now you're paying $11. Right, and that's an explosion in cost. Right, and this can become very problematic and often motivates people very quickly to look for other solutions because of the licensing and costing model of that solution. So while you get a lot of capability with this, the risks in terms of kind of distributed systems design and cost explosion issues related to what your licensing model is can become extremely problematic for people.